Hello, here we are with another example for surface area. So I want to find the surface area for the part of the function x times y that is inside the cylinder, x squared plus y squared equals 1. So here, that's the surface that I'm trying to find the surface area of. This is my restriction, my bound, and this is the region that we're going to look at it within, okay? So let's write out our formula. We have over the region, I'm going to look at so it's the partial derivative with respect to x squared plus the partial derivative with respect to y squared plus 1 dA. So that is, so the derivative of this with respect to x is just y. The derivative with respect to y is x. So if I plug that in, I'm going to have the double integral over my region of the square root of x squared plus y squared plus 1 dA. So I'm pausing a little bit because I'm not going to do this in rectangular coordinates. When I notice the region, I'm looking at, we did this in similar problems from section 15.3. I'm inside the unit disk. When we saw the unit disk, that told us to do, hey, let's do polar. If I switch it to polar, then here my bounds, my radius is going to be less than or equal to 1. Because I want to know the whole surface area inside that cylinder. I'm not just looking at when the radius is equal to 1. I'm not looking at that circle. I'm looking at the whole, everything inside the cylinder. So my radius is going to go from 0 to 1. That's an R. And then my angles, theta, is going to go from 0 to 2 pi. What that allows me to do now is I'm going to rewrite this part. This is R times dr d theta. And then now I can write my integral. This is going to be the square root of r squared plus 1. 0 to 1. Remember, that's my r. And then 0 to 2 pi. That's my theta. So then to solve this, I'm going to look at first this inside part. The first thing I want to do is I want to do the inside integral. I'm going to have to do a u substitution because I have an r squared on the inside of the integral and I have an r on the outside. To simplify that, I'm going to write this with a u substitution. So I'm going to go ahead. If you want to go ahead and finish this up, I'm going to clear the board and move my formula around a bit. I'll be right back. Okay, so I cleaned up the board and I just moved this up so we have a little more space to work. I'm going to start with the integral that's inside the purple box here. So I'm going to have to do a u substitution. So u is equal to r squared plus 1. du will be equal to 2r dr. I'm going to have to move that 2 to the other side, make it a 1/2. U's. So if I substitute this back in here, I'm going to move the 1/2 to the outside. I get 1/2 the integral. That's from r equals 1 to r equals 0 of u to the 1/2 du. So that's going to give me 1/2 times, I'm going to get a 2/3 u to the 3 over 2, evaluated from r equals 0 to r equals 1. So if I plug back in my r, I'm going to have 1/3 r squared plus 1 to 3 over 2, evaluated from 0 to 1. That's going to give me, well, when I plug in a 1, I'm going to get 2. 1/3 of 2 to the 3 over 2 minus, when I plug in 0, I'm going to get 1, that's just 1/3. So this is going to get plugged back in here to where the box was. So I have the 1/3 move to the outside, the integral, and I'm going to have so now, actually, so when I pull this one, let me fix this. When I pull the 1/3 out, this is 1/3 of 2 to the 3/2 minus 1. Let me fix that. So now I'm going to take the antiderivative. There's no thetas in there. That's just a constant. So I can multiply this. When I do the antiderivative, I'm just going to get a constant 2 pi. This is going to turn into 2 pi over 3 times 2 to the 3/2 minus 1. That's one way to write your answer. Another way that you can write that is you could simplify that exponent. This is going to be the square root of 8. So that's 2 square root of 2 minus 1. If you wanted to, you could get, just to get rid of the parentheses and simplify, they're going to have 4 square root of 2 pi over 3 minus 2 pi over 3. That's another way to write your answer. Both of them are correct. So there's an example. This gives you the surface area of the function within the cylinder.